Hey math kids, today we're going to talk about differentiation and integration of Maclaurin series. And so in this first one, we're given cosine's Maclaurin series and we're asked to find sine through differentiation and through integration. So for using the derivative, if we take the derivative of cosine of x, we'll get negative sine of x. So we can just simply put the negative sign on this side and we'll kind of rewrite this first thing. So negative d dx of this and then we want to remember that if we plug in this 0, we want to look at the first term. So if we plug in 0 here, we're going to get a positive 1. Plug in 0 here, we get a 1, so that's 1 over 1. Plug in a 0 here, that goes to 1. So all of this goes to 1. And so we're going to rewrite this as 1 plus k equals 1. So we're going to skip to the next step. All right. Now, if we take the, running out of room already? All right. I guess we'll move over here. Okay. So since we did that, now we're going to break it up into two derivatives. So we'll take the negative derivative of 1 and the first part of this summation is just a constant. So when we have a constant out in front of something that's not a constant, then the derivative doesn't really affect that. So we're going to think of the derivative just being on this piece. Okay. Now, if we take the derivative, if we actually take the derivative of 1, which is a constant, goes to 0. So we essentially just ignore this piece. And if we take the derivative of the other pieces, this one, so we still have this. Let's do this. So I'm going to bring this negative in here. So this is like a negative 1. Bring it in here. That's going to increase this by 1. And so we get k equals 1. This would be negative 1, k plus 1. Okay. And then the derivative, we bring this down in front, then we reduce this by 1. So that's how that shows up. And then if we look at the 2k here and the 2k here, we did this in a previous video, but it's just going to reduce that by 1, because it's like if we had 5 factorial, or just 5 over 5 factorial, this would be 5 over 5, 4, 3, 2, 1. 5s would cancel, and so we just have 4 factorial left over, or 1 less than we started with. So we get negative 1, k plus 1, over 2k minus 1, and then we still have this thing. Alright. Now, that is the Maclaurin series for sine of x. Your book takes it a little bit further, so I'll continue with it, but you could stop there. What your book wants to do is do n equals k minus 1. And if we do that, then we end up with this. So if this is k plus 1, we'd have to drop down 2 more, and so it's going to end up being n plus 2. Another way we could think of that is k, if we just add 1 over to it, is n plus 1. And so n plus 1 would be n plus 2. Okay, on the bottom, once again, k is n plus 1. So we get 2 n plus 1 minus 1 factorial. Then we get x 2 n plus 1 minus 1. And then if we simplify all of that, n plus 2 is a little redundant because this one is just flipping the signs. And so it's really the same thing as just saying n, because n plus 2, whether that like when n is a 1, it's going to bump it up to a 3, and 1 and 3 both give us a negative out of it. If n was a 4, 4 would give us a positive, but 6 would also give us a positive, so it's a little redundant. Okay, the bottom, 2n plus 1 factorial, and then x to the 2n plus 1. All right. Okay, so that's through differentiation. And let me erase this. And we'll do it for integration. Or do it using integration. Okay, so once again, we have cosine. We're trying to find sine. And so the first thing we want to think about is that if we take the antiderivative of cosine, we get sine. And so, yeah, your book goes through some like other stuff that I don't think is necessary. Okay, so we have sine of x, and if we do that from 0 to x, and then we just plug in this thing. Okay. Let's see. Let's get rid of this. Okay. Now, if we can kind of pull out the summation to the outside, and whoops, these should be t's, or just this x should be a t. And there we go. We can pull the summation out and just look at it like this. Okay, and then if we actually apply take the antiderivative of this, we're going to raise this by 1, divide by the new exponent, and then just rewrite like the rest of the stuff. And then we still have that same summation. Okay. Now, on this part, if we have 2k factorial and then one more, so like if we had 3 factorial and then 4, that's just going to be 4 factorial. And so the bottom is just going to become 2k plus 1 factorial. Okay. And then if we plug in, I'm going to look at plugging in 0 for the t. If we plug in the 0 for t, everything goes to 0. So remember, the algorithm is plug in the x minus plugging in the 0. So plugging in the 0 isn't going to actually do anything, and so we just need to plug in the x. And that is our Maclaurin series for sine of x.